Hi, welcome to Raw Math. Today I'm doing a series of videos on algebraic manipulation and linears. In this video, what I want to do is I want to plug in a value for r. So in this case, I'm going to plug 12 in for r and solve for q. So if I put in 12 for r, I get 12 equals 3,000 plus 4q over 500 plus q. All right, so I suggest you pause and try this on your own. Most often the biggest mistake I see is people taking 3,000 divided by 500 and 4q divided by q. The problem is order of operations says you have to divide before you can add and subtract, but there's implied parentheses, and parentheses happen before anything else, which means before you can divide the denominator into the numerator, you need to add, but you can't add because of that q. This isn't 4, it's 4 times something. So order of operation tells us there's not a lot we can do with this. However, we can multiply both sides by this 500 plus q. On the right-hand side, these guys cancel. I'm left with 12 times 500 plus q is equal to 3,000 plus 4q. Okay, so then I can distribute this in, and I get, let's see, 12 times 5 is 60, and 2 zeros, plus 12q equals 3,000 plus 4q. Okay, we will combine our q's by subtracting 4q from both sides. Make sure that when you subtract, it is from both sides. It's across the equal sign. I sometimes have people do this on the same side, figuring that they're just used to subtracting when there's a number between, but there has to be an equal sign. All right, I'm also going to subtract the 3,000 over. Nope, the 6,000. Okay, 12 minus 4 is 8. Those cancel. 3,000 minus 6,000 is negative 3,000. Those guys cancel. I'm going to divide by 8. Q is going to equal a negative 375. So we can always double check by putting it back in to make sure everything works out. I will leave that for you to do. For our next one, this is similar but different. We have that fraction again. If we put r in for 5 in for r, we have 15 over 5 plus 5 equals 3q minus 3. I have 15 over 10 equals 3q minus 3. Okay, so for those of you who've seen other videos where I don't distribute when the number goes into the number on the other side, you can do this. If you multiply both sides by 1/3, you'll see that this cleans up nicely. However, because we have a fraction over here, I'm going to reduce my fraction, so I'm going to take a 5 out of top and bottom to get 3 halves, and I am going to distribute this in to get 3q minus 9. All right, so here we go. We have to do some fraction manipulation. We could multiply through by 2, and maybe I'll do that in a minute. Actually, I think I will do that. We'll multiply by 2, and when we multiply by 2, we need to multiply both sides by 2. On the left-hand side, the 2's cancel, and I'm just left with 3. On the right-hand side, the 2 multiplies in, and I get 6q minus 18. Okay, now I can add 18 so that I have 21 equals 6q and divide by 6. Q is equal to 21 over 6. I need to reduce that fraction. So q is going to become, I'm going to take a 3 out of both, 7 halves. And we have our answer. If we hadn't done this and just added 9 to both sides at this point, so we have 3 halves equals 3q minus 9. When we add 9, what we're really going to do is add 18 halves. And if we add 18 halves to both sides, we get 21 over 2 equals 3q. And when we divide by 3, we're really going to multiply by 1/3. The 3 goes into 21 7 times, and we have 7 halves equals q. We're getting the same answer. We even have the same numbers. There's our 18, there's our 21, reduced down. I mean, if we multiplied, we would have 21 over 6. The numbers don't change. You just have to get your head around the fact that you're dealing with fractions in this situation and you're dealing with integers in this situation. Okay, I hope you enjoyed the video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks!